Pristine images promised. The telescope's primary mirror had been polished with a spherical aberration flaw. It was just slightly the wrong shape, causing the light that reflected from the center of the mirror to focus in a different place than the light reflected from the edge. The tiny flaw, about 1/50th the thickness of a sheet of paper, was enough to seriously degrade the images. While the problem was well understood, the hardware fix was time-consuming and very expensive. The rest is history. We now look in awe at the images from Hubble. In this mini project, we are going to use signal processing techniques to deblur some Hubble images. We provide you with 2 blurred images. Your task is to sharpen them and restore the full fidelity. An grayscale image can be thought of as a two-dimensional function f, x, y, where f is the intensity of the image at point x, y in the image. A RGB, red, green, blue, colored image can be thought of having 3 separate component images, a red FR, X, Y, a green FG, X, Y, and a blue FB, X, Y image. A digital image is made up of pixels. In our case, our images will be 512 by 512 pixels. MATLABassignmentexperts.com. Many optical distortions, such as blurring, can be thought of as a linear filtering operation, with the difference that 1, the functions being filtered are functions of space, not time, and 2, are two-dimensional. An image processing filter has a two-dimensional impulse response, known as the point spread function h, x, y, reflects how an impulsive point at the center of the source image is spread out in space by the filter. The operation of a linear image processing filter is that of 2D convolution of the 2D input image with the 2D point spread function. See the class handout. The two-dimensional Fourier transform is defined. See the class handout. And analogous with 1D signal processing, the filtering may be done by multiplication in the Fourier domain, that is. MATLABassignmentexperts.com. Y, J, U, J, V equals F, J, U, J, V, H, J, U, J, V, where F, J, U, J, V equals F2, F, X, Y, Y, J, U, J, V equals F2, Y, X, Y, H, J, U, J, V equals F2, H, X, Y is the image filter's 2D frequency response, and U and V are spatial frequencies with units of radians/unit length. Let's assume that the aberrant mirror in the Hubble telescope has caused the true image f, x, y to be blurred by convolution with a known point spread function h, x, y, so that the image we are given is g, x, y. The process of recovering f, x, y is known as deconvolution or inverse filtering. In one-dimensional temporal linear processing, we might do the following. By definition, the inverse filter has a frequency response of 1/h, j omega, so that f, j omega, is recovered at its output. While it sounds easy, the process can be fraught with difficulties. For example, if Hs has zeros on the imaginary axis, the gain of the inverse filter will go to infinity at that frequency. Also, inverse filters often tend to amplify any high-frequency noise. MATLABassignmentexperts.com. In the two-dimensional case, if we know the point spread function h, x, y that blurred the image, we can construct the inverse filter 1/h, j, u, j, v, and use it to restore the original. Details of the Matlab tools you might need. There are 2 blurred Hubble images to deal with. These are contained in the Matlab files blurredimage1.mat and blurredimage2.mat. Each image is a 512 x 512 RGB colored image. When loaded into Matlab, the image will be named blurred in each case. Deal with them one at a time. You can view the image with Load blurred image 1, image, blurred. Matlab has 2D FFT functions FFT2 and IF2. Don't forget that you will have to work on all three color planes in the image. The mirror design engineers have told us that the distortion was equivalent to convolution with a Gaussian kernel such as produced by Matlab's image processing toolbox function special. MATLABassignmentexperts.com. Size equals 25, sigma equals 3, h equals special, Gaussian, size, sigma. You might want to use mesh h to take a look at it. If you don't have access to the image processing toolbox, here is how you can construct the 2D kernel. Siz equals size 1/2 xy equals mesh grid siz 2 siz 2 comma siz 1 siz 1 arg equals dash x asterisk x plus y asterisk y / 2 asterisk sigma h equals exp arg sum equals sum h smiley face h equals h/sum. Note that the sum of elements is set to unity. When you have processed an RGB image and want to display it, the display function image, myRGBimage, requires that all values be real, positive, and in the range 0 to 1. MATLABassignmentexperts.com. Do not use the image processing toolbox to solve this problem. We want to see each step you took in solving the problem. Submit the listing of your Matlab script as a .m file and upload your deblurred images before 1 p.m. on the due date. Problem 4. You have probably realized by now that I just love the sound of my own voice. I used Windows Sound Recorder on my PC to make a recording of me saying good morning so that I can play it to myself each morning when I wake up. It just makes my day. Now, here's the problem. Windows Sound Recorder has a button Add Echo, which surprisingly adds an echo to a recorded sound. Unfortunately, I clicked on this button before I saved the .wav file, and the result is that I sound as if I am speaking from inside a tin can. I hate that, and I want you to help restore my voice to its natural beauty. Your job is to analyze the recorded file to find out exactly how Microsoft added the echo, and then to remove it. On the class MIT server is a Microsoft.wav file ps9prob2.wav that contains me saying good morning to myself. Download the file and load it into Matlab using the waveread function. If your computer has speakers or headphones, you can play the sound using the sound or soundsc functions. Use Help Audio to see the sound handling functions in Matlab. MATLABassignmentexperts.com. A. Given a function f, t, with autocorrelation phi ff, tau, find an expression for the autocorrelation function phi gg, tau, of a waveform g, t, where g, t, equals f, t, plus alpha f, t minus delta. Is f, t, contaminated by an echo with delay delta and amplitude alpha? Express your answer in terms of phi ff, tau. B. In the case of a discrete time signal contaminated by an echo, let Gn equals Fn plus alpha Fn minus m, where m is the echo delay. Express the echo generation as a linear filtering operation and derive the transfer function Hz. Use Matlab to analyze the .wav file using the results of Part A to estimate the parameters alpha and m that Microsoft Windows Sound Recorder used to create the echo in the .wav file. C. Using your results from B, design a digital filter that will eliminate the echo contamination from the .wav file.